Assalamu alaikum. I am Muhammad Ali Ahsan, the computer teacher from the City School University Road campus. And today we'll be studying the topic computer architecture. So today we'll be looking at what's there inside the CPU, what's there inside the microprocessor chip that you have seen. So let's start. So this topic is topic 3.1, that is computer architecture. Okay, so the first question that arises in the mind is, what is a central processing unit, or what is CPU? So I'm sure you must have heard that the central processing unit is actually the brain of a computer. So basically it is responsible for doing all the operations that are going on in a computer. It is responsible for doing all sorts of calculations, all sorts of work on your computer. So we can say that the CPU processes instructions and data that are input into the computer by different input devices. Like for example, the data that is inputted into the computer by a keyboard, the data or instructions that are given to a computer by a mouse, or the data that is given into a computer by a touchscreen are processed by the CPU. And this processed data is displayed on the output devices like the monitor or the printer. So the processed data is given to these output devices by the brain of a computer, which is actually called the central processing unit. So this is the basic definition of what a CPU is. Now moving forward, how does a CPU looks like from inside? By CPU, I mean the microprocessor chip. The chip which looks like this, how does it look from the inside? What is there inside this chip? So this is what we are going to study in the topic, that is computer architecture. So let's begin. Before talking about the latest architecture of the computers that we have today, we need to look at how this architecture used to look like in the past. So what's there in the past, the computers that were there, they were not very much automatic. A number of things had to be fed into those computers by the human beings. And so we can say that there was too much human intervention involved in the early computers. The main issue was that the old computers were unable to store data, programs, and instructions like our computers do these days. So guys, these days we just press a power button of our computer and we see the operating system loading on our computer. We see the files and applications running on our computer. We see the operating system loading on our computer, and each and everything is done automatically. And this happens because you have this data, you have these applications stored on the hard disk drive on your computer. But when you talk about the early days computers, they were missing the element of memory. So because of which all the programs, all the data have to be provided to the computer by a human being. And so we can say that there was a lot of human intervention involved. So then what happened? There was a person whose name was John von Neumann. And I'm talking about the year 1945. He realized this problem, and so he suggested that there should be a stored program computer, which means that the programs and data does not have to be fed into the computer by the user, but they will be stored into the computer already when someone is going to turn on the computer. So we can say that John von Neumann gave the concept of computer architecture, a stored program computer. And so on his name, this architecture has been named as von Neumann architecture. So what was his basic idea? His basic idea was that the programs should be stored in a computer memory. And whenever any data is required by the central processing unit, that data will move from the computer memory towards the processor. So this was his basic concept. This was his basic idea that was given by him. So let's have a look at the block diagram of how von Neumann architecture looks like. Okay, so this is how the von Neumann architecture looks like. And as you can see here, that here we have, you can say here we have three basic units. What are they? Number one, the main thing, the brain of your computer, that is your processor. Another component is the memory unit, where all the programs and data will be stored. And the third one is input and output devices, which will be used to give an instruction to the computer or to display the result to the user. Input and output devices. So we can say that basically we have three main components. And remember, we are currently looking at the simple model of the one human architecture. In the upcoming slides, I'll be showing you the detailed architecture of one human architecture. But according to this basic model, according to this simple model, we have three basic units: processor, memory, and input and output devices. And along with that, you can see that there is a component which has been shown inside the processor, that is your control unit. Okay, so this is the basic design. Uh, Along with that, you can also see that all these three units have been linked together with each other with the help of connections, which are actually called buses. Guys, remember in computer science, the connections or for the wires, we use a term that is called buses. So this connection that you see here, I'm talking about this one. This connection that you see here, I'm talking about this one. And this third connection that you see here, all of them are called buses. And buses are basically the wires through which different components of the computer architecture are connected with each other, are joined with each other. Okay, so this is the area, this is the connection from which data or instructions travel between different components of the computer system. So this is the simplest model of the one human architecture. But now let's move forward and let's see the advanced version of this particular model. Okay, so guys, this is a detailed model of one human architecture. And here you can see that multiple units have been shown here. Like for example, this control unit have been shown separately. In the simplest model, I have shown you that it was part of the CPU. But here in the detailed model, it has been shown separately. Along with that, input and output devices have been shown separately. So we have input devices, we have output devices, and memory unit has been shown here. And the main component, that is brain of your computer, the processor, has been shown here. Okay, so now let's go into the details and let's see what do we have to study regarding each of the component inside the computer architecture. Okay, guys, starting with the first thing. So the first thing that you're going to note here is that inside each of the component, further subdivisions can be shown, can be seen. Like for example, in the control unit, you have this thing that is has been mentioned with the abbreviation PC. Another box here which has been mentioned, specified as CIR. A few other blocks are here inside the memory unit, like for example this one MAR, or this one that is called MDR. Along with that, even in the processor, you have two blocks which are can be seen as ALU and accumulator. So now we need to understand what are these blocks doing inside each of the unit. So let's check them out. So in order to understand this, I'm going to give you an example. See guys, the purpose of having these sub blocks inside these units is, let's say that if the control unit wants to give some data, if the control unit wants to share some data with the memory unit. Okay, so broadly speaking, we say that control unit shares some data with the memory unit. But if you're going to go into the details, so this is not what is actually happening. Actually, a register, so actually these boxes that we see here, they are called the registers. These sub blocks or the boxes that you see here, they are called the registers. So remember, whenever any unit of the computer architecture wants to share some data with some other unit, so that unit does not share the data with another unit, but actually its register, which is this block, shares some data with the register of the another block. So let's say if control unit wants to share some data with the memory unit, So the register of the control unit, which is PC, it is going to share the data with a register of the memory unit, that is MAR. Okay, we are going to see each of these registers in detail in the upcoming lectures, in the upcoming slides. But right now, remember that these sub blocks or these boxes inside each of the unit, they are called registers, and they are used so that data can be manipulated within the computer, so that the data can be moved between different units of the computer, so that the data can go from one register to another. Okay, so this is the purpose. They are used so that data can be moved inside the computer's architecture. So this is the reason behind. Okay, so I'm again repeating, here we have a memory unit, we have a processor unit, we have a control unit, and along with that we have input and output devices. Okay. If this is clear, now let's move forward. Okay, so from here we are going to move forward, and we'll be looking at how these registers behave, or what is the purpose of each of these registers in a topic. You can say that is the most important topic from this particular area, that is computers architecture, and that topic is called fetch execute cycle. The topic is called fetch execute cycle. So guys, let's study that. Let's see what is fetch execute cycle. Okay, remember what we studied was that the data is there inside the computer memory, and whenever any data is required, that data will be fetched, will be given to the CPU. So this is the basics of fetch execute cycle. But what we are going to study here, we are going to study how different units of the computer architecture along with their registers play a role so that data can be fetched and so that it can be executed. Now, before moving forward, again, I am repeating what are registers. Registers are temporary memory areas inside different units of a computer. And remember, they are used so that data can be manipulated within the computer so that the data can move from one unit to the other. Okay, now let's study fetch execute cycle by looking at a block diagram that I'm going to draw on my whiteboard. So guys, let's start. Okay, to understand how fetch decode execute cycle works, I'm going to show you a diagram. So remember the basic units that we have in a computer architecture. We have a control unit here. So I have shown you that control unit has two basic registers, which are PC, and the second one is called CIR. Okay. Then you have another unit here, which is the memory unit. And if you remember, memory unit has two basic registers, MAR and MDR. Okay. Then let's say here I have my processor unit. Having two registers, ALU and accumulator. And definitely input and output devices are also here. So let's say here I have my input devices, and here I have my output devices. So that is obvious. Okay. But for the time being, I'm not considering input and output devices, but you know that they are here. And I'm ignoring them, and I am considering that the data that I'll be considering is stored in my memory. Okay, so let's see how different units are going to play a role in fetching the data from the memory and executing and running that data by the processor. So the first thing is, let's quickly see what is the role of each of the register. So let's start with the first one, that is memory address register. Remember, every data which is there in your memory, it is stored at a particular location, and the address of that location is stored inside this register, which is called MAR register. Moving forward, the data itself which is there in your memory, whenever that data has to go out, or whenever that some data needs to be stored into the memory, so first it is stored inside the register MDR, and from here it can go inside the memory. And where will it go? It depends on which location has been mentioned in MAR. So MAR contains the location of the data, where it will be stored or where it is stored in the memory, and MDR contains the actual data. Now moving forward with control unit. Remember, PC is a register of control unit that contains the address of the memory location of the next instruction which is to be executed. Why am I saying next instruction? Because the instruction that is currently executing on your computer gets stored inside the register CIR, and the instruction that will be executed next, its address will be stored inside the register PC. So again, I am repeating, PC will hold the address of the next instruction to be executed, and CIR holds the current instruction. Moving forward, in processor, I have two main registers, ALU, which is responsible for carrying out all the arithmetic operations like addition, subtraction, multiplication, and division, as well as all the logical operations like AND, or not, or maybe comparison of two numbers. So this is the role of ALU, mathematical operations. Whereas, remember, the data on which ALU is performing some operation, that data has to be first stored inside a register that is called accumulator. So until and unless the data is not stored in the accumulator, ALU cannot perform any operation on it. So the data on which some operations will be performed, that data is first stored inside the accumulator register, and then the ALU will perform an operation on it. So that is how it works. Okay, moving forward. Now, just to give you an example, I'm going to consider a program, a simple computer program. So let's say I have a computer program in which the first instruction is input number, and let's say the second instruction is 02, input num2. Okay, and let's say that the third instruction is sum equals to num1 plus num2, and let's say the fourth instruction is output sum. Okay, so let's consider that this program is stored, it's there inside your memory. Okay, we are, for the time being, we are considering that this program is stored inside my memory. Now let's see how each of the instruction will be fetched and how each of the instruction will be executed on the computer. So guys, when the program will run, when the program will start for the first time, so initially what is going to happen, the address of the first instruction, that is, the address is 01. This address will go inside the register PC. Okay, when the computer will run the program for the first time. So the address of the first instruction will go inside a register PC. From this PC, this address will be transferred into the MAR register, okay, which is the memory address register. Remember, the program is there inside your memory, and control unit will help fetch the data, fetch the program instructions from the memory, and it will give those instructions to the processor. So the address of the first instruction, which is obvious, that is 01, that is actually there inside your PC, because definitely whenever a program will start, the address of the first instruction is what? The address of the first instruction is 01. So let's say that the address of the first instruction, that is 01, it's there in your PC, and this address has been moved into the MAR register. So now MAR is having a data of 01. Okay. After that, what is going to happen? Then what is going to happen? the processor is going to send a read signal to the memory unit like this. Okay, now when this read signal will arrive, the data which was present in your memory at location 01. So at 01, you have this instruction that is input num. So this instruction will be moved into the register MDR when the read signal will arrive. Now from here, this data which is there in MDR, this instruction that is input 1, this instruction will go inside the register of a CPU, that is of a control unit, that is CIR. Because I told you that CIR holds the current instruction that is being executed. So from MDR, this instruction that is input 1, it goes into the CIR register. And from CIR, this instruction will move towards the processor, where this instruction will be decoded. Decoded means that the CPU will understand what is meant by that instruction. And after that instruction will be executed. Okay, so this is the fetch execute cycle. But since we are calling it a cycle, so this is a repeated process, which means that what is going to happen next, the value of PC will be incremented by 1. So 1 plus 1, that is going to give me an answer of 2. Okay, so from PC, this new address, which is basically 02, this new address will go into the MAR register, that is memory address register. So MAR is now holding the address 02. And then again, when this read command will arrive into the memory unit, so what is going to happen? The instruction which is present at location 2, this instruction will now move to the MDR register. From this MDR register, now this instruction will move to the CIR register. From this CIR register, the instruction will again move towards the processor, where it will be decoded, and finally it will be executed. So guys, this is the complete process which is called the fetch execute cycle. So sometimes we take the full name and we call it fetch decode execute cycle, but in short we simply call it fetch execute cycle. So that's all for today from my side. Thank you so much for listening to this lecture. Hope to see you again. Allah Hafiz.